Alkyne hydroboration again proceeds similarly, initially at least, to the hydroboration of alkenes. If we treat a terminal alkyne with borane of some sort, it doesn't necessarily have to be BH3, it could be anything with alkyl groups in it and one BH bond. We will initially get anti-Markovnikov addition of Br2 to the less substituted carbon and hydrogen to the more substituted carbon. After hydrolysis, we'll remove the boron and install oxygen instead, thus getting an enol again. And this enol under basic conditions will rearrange into the final product, and that will be an aldehyde. Now, we've seen previously that under acidic conditions, this keto-enol tautomerization occurs readily. But in this case, it occurs under basic conditions. So let's see how does that mechanistically work. If we have an enol in the presence of base, this species will be deprotonated to some extent. Generating an anion here. And this anion again will have two resonance structures. One will have a minus here. And now the back attack of this anion onto molecule of water will restore the proton here, give us CH2 group, and finally leave us with a COH group of an aldehyde idea. And so this will be a base catalyzed keto-enol tautomerization. And the crucial step in that keto-enol tautomerization is not really the enol itself, but this enolate anion, which is then isomerized into a given aldehyde. To illustrate all this with an example, if we have this alkyne, model alkyne, and we treat it with borate and sodium hydroxide, or the hydrogen peroxide. In this case, we will get an aldehyde. However, if you take the same compound and treat it with acidic conditions, H2SO4, mercury, and water, we will end up with a ketone. And both are derived through the keto-enol tautomerization. In both cases, the enol is the original product, which is then isomerized into ketone or aldehyde under acidic or basic conditions. So you can see that Markovnikov rule still applies. We still have that fundamental ground, but what follows afterwards is a conversation which gives us differential products.